I like lipids because they make my mouth work. They give my tongue a workout. So, in this next classification of lipids, we're going to look at these things called sphingolipids. Well, we've taken a look now at a couple of different families. Fatty acids was one of them. Our phospholipids was another. We talked about now these vitamins, or at least vitamin E, tocopherol. That was a word that gave my mouth a workout. And now we're looking at sphingolipids. And sphingolipids are another classification of lipid. The difference, though, is how they're made up. Do we have a glycerol backbone, or is it modified? Do we still have these carbon tails, or do we have something else other than a carbon tail on them? So we're going to look at this video, and we're going to kind of hone in on what a sphingolipid is. What are some of the components that classify as a sphingolipid? And then what's their purpose and why are they so important? So with sphingolipids, there are basically two different types of sphingolipids. We're going to look at something called a sphingomyelin. Sphingo, so sphingolipid, but it's a special type of lipid, and these are called myelins. So sphingomyelins, and then we're also going to look at another Sphingo brand, and these Sphingo brands are not going to be called Sphingo at all in their common name, but what we use here is something called Cerebro in the front, and these are Cerebrosides. So we're going to look at the family of sphingolipids. We're going to break them down into two groups, sphingomyelins and cerebrosides. And we're going to take a look at the common things that they have, and we're going to take a look at what makes them different and why are they so important. So let's first start with our sphingomyelin. So up here at the top, I'm just going to put a 1, and then down here I'm going to put a 1, and we're going to draw the structure or the template of a sphingomyelin. So instead of a glycerol backbone, this actually has a 4-carbon backbone instead of a 3-carbon backbone as glycerol did. So that's one of the differences. This is not a glycerol-based lipid. This is a different type of lipid that has sphingosine as a backbone and not a glycerol as a backbone. So sphingolipids contain an amino alcohol, and this is called sphingosine, and this is the start of the sphingosine for us. So 4 carbons, not 3. That's one of the major differences here. On this carbon, we have a nitrogen, and that's attached to a carbonyl, and that's attached to an R group. So this is our amide in a way, C double bond ON, that is classified as an amide. So hopefully you took that away from last semester. You know what that functional group is. On the second carbon, this is traditionally just an OH group, so that's all that's there. And then on the top carbon, we have a double bond that's starting off with this chain, and this is a CH, parentheses, CH2, and there's typically 12 of these here, and then a CH3 group that's there. So the first carbon has this traditional hydrocarbon tail, like we've seen in these other lipid structures. And then the second carbon has a polar OH group. The third carbon has some polarity in the beginning. We see this amide functional group. And then this R. It can be anything that it wants to be after that point, but an R group that follows. And then the very last carbon is very similar to a phospholipid, because what we have here is an oxygen that has this phosphorus on it, just like the phospholipids did, and then we see an OCH2, CH2, N, a CH3, a CH3, and a CH3 group that's here. Please note, you've seen this type of functional group before, this one here, And this functional group we discussed in phospholipids. And if you take a look, this is what we call the phosphatidylcholine. This is our choline structure. And we call that the lecithins. All right, so we see choline coming in here as well. And if it has choline, or we could also draw the ethanolamine structure that's there. So I'm just going to put an arrow here, and I'm going to say this is choline, or you could also have drawn ethanolamine there as well. Either one of those groups would have worked at this position. And if you've got this setup, then you have what we call a sphingomyelin. Now, why is sphingomyelin very important? Well, that's because all of your nerves have this coating around them, and this coating is basically made up of sphingolipids. So sphingolipids are very important because if your nerves basically talk to each other, then they're talking to each other because of this sheath that we put around them. Typically, we call these the myelin sheaths. And these myelin sheaths will basically give electrical discharges between each other, and these nerve cells begin to talk each other because of that. And if we start to degrade those myelins, sphingomyelins, if we start to degrade those, if we start to remove those, if those suddenly do not work anymore, then our nerve cells do not talk to each other anymore. And if our nerve cells don't talk to each other, then what you typically see is a very slow form of paralysis. And this is something, of course, that we want to prevent if we see it coming. So the myelin sheath is a lipid-rich area in your body, and this works because of the lipids that are there. They are wrapped around these nerve cells, and these nerve cells talk to each other because of the presence of that sheath. So these sphingomyelins and cerebrosides, we've not taken a look at cerebrosides yet, but these cerebrosides also play a part in the picture as well. But this increases the velocity of these signals. And if they begin to degrade, we call this multiple sclerosis. So MS for an abbreviation. And this is what happens to people that are experiencing or that are diagnosed with multiple sclerosis. This MS diagnosis is due to the fact that these lipid bilayers, or these lipids, these sheaths, are basically getting destroyed over a course of time. Some people, it happens quickly. Other people, it happens at a very slow process. And if this very slow process continues, the nerve cells do not talk to each other anymore, and these people typically end up with some form of paralysis on them. So here is a diagnosis, a little bit of medical that is bringing in on you into these lipid lectures, but it's very important to kind of associate and apply some of the stuff that you learn to real life situations. So choline or ethanolamine can go in this spot down here, and we call that a sphingomyelin. Now, our second one that we had up here at the top, the second one is called a cerebroside. So let's take a look at what a cerebroside will look like. Just like before, the cerebroside is a 4-carbon chain. So it is not a glycerol. It is very common to my sphingomyelin here. And on this top carbon, it's a double bond CH parentheses CH212 CH3. It's the same group that my sphingomyelin had. There's no difference there at the very first carbon. The second carbon is an OH group. Just like before, there's no difference in the structures here. The third carbon, we see a nitrogen, and we see a carbon, and we see an alkyl group. There's no difference to this one either. Same as before up here at the top. The problem is this very last carbon. And in this very last carbon, we have a group that is different. And this is what makes it a cerebroside. So I want you to go back and I want you to think about some of the ways that we named these polymers of sugars. And if you go back and look at the way that we named those and the endings that some of them got, you will see side listed there. So if you kind of relate that to a name and a structural property, it should not be surprising that this last carbon contains some type of sugar. And what we see here is an oxygen. And off of that oxygen, we have a six-membered ring. And this six-membered ring, 1, 2, 3, 4, 5, and 6. Off of one of these oxygens, of course, you're going to get an oxygen. So we see an oxygen that's here, and then like those sugar molecules, a CH2OH that will hang off of there as well. And then on each one of these, that of course was the oxygen involved in that OH group. We're going to see an OH group that's here, and an OH group that's there, and an OH group that was here. But the thing continues to circle around as we go through. So this is kind of the template of this cerebroside that we can talk about with the Sphingo family. And that's really the only difference, is that on this very last carbon of this carbon chain, we see a sugar residue that's listed there. Instead of one of these ethanolamine or choline groups that's up here at the top. Okay, so this is the story with the sphingolipids. We've now talked about phospholipid and sphingolipid, but there's something that I want to mention more about the phospholipid family, and especially lipids in general. So in the next video, before we go forward and talk about these things called prostaglandins, I want to take a few minutes and just cover two topics that you probably want to know more about. And one of those is going to concern snake venom, and the other one is going to concern chocolate. So who would have ever thought that we would have been talking about chocolate and snake venom in the same sentence? So stay tuned. In the next video, you'll see what that's about, and you'll see how that will relate to the lipid family.